Okay. Hello everyone. Today I will be presenting our paper titled Dynamics of the Upper Floor, a Model-Based Assessment. So this is co-authored with Jonathan Smith and Marcio Bassanin of the Bank of England, and the usual disclaimer applies. So let me give you a brief motivation of this paper. So prior to the output floor, this output floor hasn't been introduced. It will be introduced in 2023. So the Basel framework allows banks to calculate risk weights using their internal model. So this has clear advantages in the fact that banks are not penalized for holding the safest assets. And then second, since banks are the closest to the sources of risk, it's just proper that they're able to estimate the risk measures more effectively or efficiently. But the global financial crisis have shown that there are significant limitations of the model-based approach. One is that the risk weights have failed to reflect the bank's portfolio risk, and this generated an excessive volatility of the risk-weighted assets. And second, that internal models may suffer from both informational and incentive problems because banks have the tendency to underwrite risk in order to gain capital requirement discount. So to solve this problem, in 2017, the Basel Committee on Banking Supervision introduced a new set of reforms known as the Basel III Finalization Package. And this includes the output floor. So the explicit objective of the introduction of the output floor is really to restore the credibility in the calculation of the risk-weighted assets. So as I've mentioned, these output floor hasn't been applied yet, and it will be introduced in 2023. So policy institutions have started to assess the effects of the output floor. However, a comprehensive assessment of the macroeconomic of the impact of the output floor has not been performed yet, and this paper will try to fill that gap. We use a DSGE model to assess the macroeconomic effects of the output floor. So briefly, what is the output floor? So the output floor is a new floor that aims to enhance the reliability and the comparability of the risk-weighted capital ratio. So this is intended for all banks that use internal models. And the way it works is that the output floor limits how the internally modeled risk-weighted asset can fall relative to the standard approaches way of calculating the risk-weighted asset. So they have a threshold at 72.5%. So why the output floor? So from a policy perspective, the output floor guards against the risk understatement, especially for firms that use internal models. And it also will maintain or label a level playing field between banks that use internal model and banks that uses standard approach. We find in this research that indeed the output floor reduces the procyclicality of risk weights, and the output floor helps the regulator in smoothing the credit cycle. So let me give you our complete contribution here. We developed and estimate a DSGE frameworks with the underpinnings of the output floor. What we do is then we have a banking sector, and we subject this banking sector, one with the model with the internal risk-based model, and one with the output floor. We then compare these two models, and we find that there is an improvement when we introduce the output floor. One is that it contributes to tame the credit cycle. And second is that the output floor reduces the variability of the macro and financial variables. However, there is also an unintended consequences with the introduction of the output floor, and that is it may incentivize banks to shift their portfolio from a less risky mortgage to a more risky non-financial corporation loans. So I'll discuss quickly what we have. I'll discuss the model, the estimation, and the result. So the main model, so this is a DSG model. We have household with savers and borrowers. We have a productive sector, the banking sector, and the central bank that imposes the monetary and prudential policies. In the banking sector, we have two assets. We have the mortgage, which is the less risky asset, and we have the non-financial corporation loans, which is the more risky asset. So what the banks do is to maximize its profit by extending credit to household or to credit, which is the mortgage and the non-financial corporation loans, minus their cost of as payment for the sources of funds, which are the deposit, minus also the credit constraints. And this is where the output floor comes in. In the risk-weighted asset, we then solve the model. One, where we calculate the risk-weighted asset using a model-based or the IRB approach. And the second one would be the output floor. And then we then compare the model and see which model performs better. So from here, we have the model. So to pin down the parameters of the model, we use UK data to estimate the model. And that's the data from 1991 to 2019 at a quarterly frequency. And we find that the total factor productivity and the non-financial corporation loans are the key drivers to the credit to GDP fluctuations. So we use these shocks to simulate the model and compare the model with the output floor and the model with the IRB way of calculating the risk-weighted assets. So here are the key results. As I've stated earlier, we find that the output floor reduces the excessive credit expansion during an economic boom and mitigates the credit contraction during the bust. We find also that the output floor reduces the variability of the main macro and financial variables, and it helps policy authorities to achieve their objectives. However, we also find that the output floor may incentivize banks to shift their portfolio from a less risky mortgage to a more risky non-financial corporation loans. So quickly, these are the results. Here in the blue dotted panel, the upper panel, it shows the risk weights of the model with the IRB or the internal model approach and the model with the output floor. So this is a 1% positive total productivity shock, and we see here that when the model is hit by the shock, the model with the internal risk-based approach, risk weight drops compared to the model with the output flow, where risk weights is stable. And this affects the risk-weighted asset. So here, the model with the IRB approach, risk-weighted assets drops, and this has an impact to the capital ratio, and would then lead to an impact to credit to GDP. So here in this result, we highlight that the model with the output floor, the red solid line, attenuates the credit expansion during booms. It also alleviates sudden credit expansion during the crisis or during a crisis. And here is another assessment where we compare the volatility of macro and financial variables for both models. And we see that the model with the output floor has the lowest volatility. We then also compare the loss function of both monetary authority and macroprudential authority, and we see here the model with the output floor has the lowest loss function. So this means that other things equal, the output floor can help regulatory authorities in achieving their objectives. And lastly, this is the highlight of the third result. We see an asymmetric response of both the mortgages and the non-financial corporation loans, as you see in this blue dotted panel. So this means that banks may be incentivized to change their portfolio composition when we introduce the output floor. That means risking up or de-risking for moderately or low risk portfolio respectively. So to conclude, what have we done in this paper? We assess the macroeconomic effects of the output floor, and we do that by developing and estimating a DSGE model with the underpinnings of the output floor. And we find that the output floor contributes to tame the credit cycle. It also reduces the variability of the macro and financial variables. However, it has an unintended result, which is it may incentivize banks to shift their portfolio from a less risky mortgage to a more risky non-financial corporation loans.